आइए हम सुने विज्ञान की अनकही कहानियाँ। आइए हम सुने विज्ञान की अनसुनी कहानियाँ। एक नई दुनिया की आवाज़ आपकी आवाज़, विज्ञान की आवाज़, की आवाज़।
Celebrating Azadi Ka Amrit Mahotsav, we bring you a podcast series on STEM popularization, science, technology, engineering, mathematics and medicine, supported and catalyzed by the National Council for Science and Technology Communication, Government of India. This program is produced by Media for Community Foundation. Creative content and technical support is given by Purvasha Banerjee and Shushanto Das.
एक नई दुनिया की आवाज़ आपकी आवाज़, विज्ञान की आवाज़, की आवाज़, की आवाज़।
Indian Statistical Institute is a public university which is recognized as an institute of national importance. It grew out of the statistical laboratory set up by Prashanta Chandra Mohananobish in Presidency College, Kolkata. Established in 1931, this unique institution of India is one of the oldest institutions focused on statistics. Primary activities of ISI are research and training of statistics, development of theoretical statistics, and its applications in various natural and social sciences. In this podcast, we welcome Dr. Raghunath Chatterjee, who is a professor and head of the Human Genetics Unit at Indian Statistical Institute, Kolkata. Sir talks about oral cancer, which is an extremely prevalent condition in men in India.
Myself, Raghunath Chatterjee, currently professor and the head of the Human Genetics Unit, as you mentioned. So I did my master's in physics, and then I started working. My PhD was in biological science. Mainly, I focused on the genetics, genomics. And after completion of my PhD, I went to USA. I worked at the National Cancer Institute, USA, and I worked mainly on the epigenetics over there and transcription biology and how the gene regulation is actually governed by the epigenetic mechanisms. So after staying over there for around 5 years, so I came back to India and joined Indian Statistical Institute Human Genetics Unit. So and primarily working with genomics and epigenomics in human health and diseases. So currently we are focusing on two diseases. One is psoriasis, which is a skin disease, and another is oral cancer. And most of you know the oral cancer, which is one of the most prevalent disease among the men in India. Primarily, I'll now talk about oral cancer, which is one of the major disease, highly prevalent among the men in India. And you know the reason, because the habit of smokeless tobacco, the smoking and alcohol consumption, you can see it's across the world, right? But particularly this part of the world and some of the South Asian countries, including India, so there is a habit of chewing different kind of smokeless tobacco. The like pan, okay, the betel quid, and gutka, such kind of smokeless tobaccos are there. And probably that is the primary reason that we see a high prevalence of this oral cancer among them. So there are two ways to handle this disease. One is, if you detect the disease, then go for a treatment. There is a surgery, chemotherapeutic intervention. So those are the one strategy. Another strategy that actually what I thought about and then I started working on that area is whether we can actually screen it in early stage so that the disease can be actually cured. So the early detection is one of the research problem that I started working. And as I said that like I work on the epigenetics, so I specifically focused on, because in early stage of the disease, we see that there are a lot of changes, the epigenetic changes. So what we did essentially, we started with taking the tissue samples, oral cancer and adjacent normal tissue samples, the cancer tissue and the normal tissue from the adjacent area, and did a genome-wide this epigenetic profiling, mainly focusing on the DNA methylation, and then identified that what are the differentially methylated regions, those chemical modifications, the DNA methylation. So they are actually different in the tissue region, the affected tissue, the lesion, cancer lesion, compared to the adjacent normal region. And then we identified a set of those differentially methylated. So the idea was to take those differentially methylated regions and then see whether these can be used to classify these. So we started with that idea, and then we did a lot of biological knowledge that we gathered during my area of research, starting from PhD to postdoc, and then use those concepts to actually shortlist, because we found around 2000 differentially methylated regions. But it's very difficult to profile all those things. So we did a feature selection just using a biological knowledge. And with that, and then finally we use different kind of the machine learning algorithms to actually came up with 5 regions which can actually clearly distinguish the normal and the affected cancer region. And with those 5 regions, so not only we have considered those 5 regions, so what we did essentially, so we started with a genome-wide mapping of those CPG, identification of those genome-wide methylation profiling. But you cannot ask the patient to go for the genome-wide that test. So that test will be little costly. So what we did essentially, we took different kind of methodology to identify the CPG methylation and see whether if you change the method of identifying the CPG methylation, whether those can also be used in the model to predict the disease. So we tested different methodologies. One is pyrosequencing based, another is droplet digital PCR based method. So that method we actually developed first time and use that, and we use those methylation profile and put it into the model, and we found that with 95% accuracy we can actually classify these normal and disease. But that was good in one sense, that in research level we found some important regions, and these are only the 5 regions which can be used to classify the normal and disease. But whether the question is that whether this can be used actually for the human population for the screening purposes, because you need to have a tissue. So what we decided that taking the tissue is an invasive process. So instead of doing that, we took 2 different strategies. One strategy was, instead of taking the tissue, we took the swab sample from the affected skin and the adjacent normal skin. And from there actually we did profiling of those 5 regions, and we found that with the swab tissue also, whatever the methylation profile you are getting, when we put into that model, we can actually classify the normal and disease very similar accuracy. So the accuracy is not actually getting compromised. And before actually doing the swab test, what we did essentially, there are more than 1200 different such patient samples data were available across the world. Like we got the data from 7 different countries, and from all 7 different countries, we took the data and tried to identify whether the model actually can be used only for the Indian patient or it can be used for the general population across the world. So we took all those 7 different countries, and we found that the accuracy of the model is actually almost constant across the different countries. So it's essentially not a region specific, although we have the initiation of the disease is caused by those different smokeless tobacco and habit, but we come up with a model which can be actually used across the world. So that is one thing. The second thing is, as I said, that to invasive to non-invasive, so we took a swab samples, and with those actually we identified again a very similar kind of accuracy for that model. But we did not stop over there, because again, swab only if you can take, if someone is coming up, to your clinic, to the doctor's clinic, and there is a lesion, then you can actually do the swab and do this test. So what we did, that we thought that like can be used for the screening purposes only if you go to general population and ask for some biological sample which is easy to obtain. So we started working with the saliva. So we took the saliva samples from the normal individuals and the disease individuals, and then we actually with the saliva samples. So these we are still, this is ongoing work. So we have industry collaboration, and they are also going to fund us. And we also got funding from the CSIR, Government of India. And also we have a translation innovation hub here. So I have a primary discussion with them also. So probably we are going to get fund from there also. So we are actually trying to do it with the saliva samples, and we will incorporate not only those methylation, some other features so that we can enhance the accuracy of the model. So that is essentially for the oral cancer for detection in the general population level after taking a very easy to get sample, which is essentially the saliva.
We heartily thank Professor Chatterjee for sharing with us his knowledge and experience.